Come on, Mom, come on. Happy birthday, Dad. I love you. Bye.
So how are we going to figure this out? What's a good strategy to take?
So,
What's the first thing we should probably do? In other words, we wouldn't necessarily need to do it if we were just doing 9a. We could just fill in that for x and see if we get a y of 1. But
yeah.
the rest of the questions talk about vertical asymptotes, horizontal asymptotes. Maybe we should try graphing this thing.
Okay.
Okay, so that's what I would suggest we do. That might make some of the others easier to do.
All right.
Well, here's what natural log looks like. Almost all of them. In fact, if I draw that, you can say that that's the natural log graph, but I don't know what base, because they all go through that point right there, no matter what base. So
Okay.
that could be y equals log base anything of x. It would all look like that. Okay? So ours is a translation of that. So let's figure out what our function's going to look like. Things going on. We got that. What does that do?
So that moves the graph to the left 1.
Okay, so since our only reference point here is this point here, I'm just going to move it over to here. Okay. The other reference point is our vertical asymptote. In other words, we actually had a vertical asymptote of y or x equals 0, and now we have a vertical asymptote of x equal minus 1 because we had to move it over to the left by 1.
Right.
For that, when you're thinking vertical asymptotes, if you're making a horizontal shift, you got to shift that thing also. This going to look like that. Okay. So that's that part. What's the consequence? Is that a negative 2?
Okay. So,
Is that a negative 2?
yes.
I can barely read it. So what's the consequences of that?
So, it goes down 2.
Okay. Again, the blue curve, we want to apply that change to, right? So that point goes down 2. So that's a new reference point. 0, comma, minus 2. So that point's on our curve. That does not change our vertical asymptote. Our vertical asymptote stays at minus 1. So
Okay.
what I do is something like that. So there you have the red is the original non-transformed. The blue is the first transformation. And the green is the entire transformation. Okay? So we're kind of interested in the green. So that's the curve we always want to be looking at. Now, let's see how to answer that question right there. Does it go through that point? Well, for that to be true, this would have to be true. 1 would have to equal the log base 4 of 4 plus 1 minus 2. Is that true?
No.
No, it isn't. We don't know what the log base 4 of 5 is, but it's certainly not a whole number. It's certainly not 3. And for this to be true, that would have to be 3, right? In other words, for 1 to be equal to that minus 2, that whole thing circled would have to be 3. And it isn't 3. I mean, you could look it up in your calculator. I don't know. They can't really keep you from using your calculator on homework problems, can they? So they give
Yeah.
you permission to use your calculator. So
Yeah.
you could well prove that that is not true. The graph has a vertical asymptote at x equal minus 1. True or false?
True.
Graph has a transformation that is left 1 and down 2.
Yes. True.
Graph has a horizontal asymptote at y equal minus 2.
False.
Graph passes through the point 0, comma minus 2.
True.
Yeah, because does that mean this is true? That's always 0. The log of 1 is always 0, no matter the base. So yes, that is true.
Okay.
And the graph decreases over its entire domain. Well, first of all, what is its entire domain? They screwed up there.
So,
The way I've drawn it, what is its domain?
negative infinity to infinity.
No?
Or actually, no, it's -1 to infinity. Sorry.
Correct. In other words, what they gave you was the domain of my red, the non-transformed parent function. But nonetheless, is that true or false?
It's false.
Yeah, it in fact increases the entire domain. In other words, you see that where it's always increasing?
Yes.
And there is no horizontal asymptote up there. There looks like there is, but there isn't. It's very easy to look at a log chart and think that there's a horizontal asymptote because it looks so flat. I don't know if I've ever told you this or not, but this is the flattest function you'll ever see. And in fact, you got to go 2 miles in that direction in order to go up 12 inches.
Okay.
That's how flat that thing is. 2 miles to go up 1 foot. That's 10,000 to 1 ratio.
Okay.
All right, number 10. Oh, and I see we got Newton's law of cooling again also. They
Yes.
start giving you a lot of Newton's law of cooling, considering I've never had a student that had that without taking pre-calc. This is just an honors algebra 2 course, isn't it?
No, it's not.
What are you taking?
Just normal algebra 2.
That's right. That's even more astounding that they're giving you this much Newton's cooling in algebra 2. I wonder if that's a new thing this year, because I have never encountered that before. I've been tutoring algebra 2 for like 9 years. Which school do you go to?
Pomona.
Pomona, okay. Maybe it's just Pomona. All right, number 10. Population of rabbits, 60 days later, the population has grown to that. Write an equation of exponential growth and decay. Well, what is the general form of that equation?
Y equals AB to X.
Yeah. I suppose this is the one they want you to use. I'm not sure exactly why they wouldn't want you to use this one. I guess A is P and B is E and X is RT. But they both are exponential growth. Okay.
Right.
The advantage of using this one on the right is that in this case, we should be able to solve for A and B. And then we would have a specific equation that applied to rabbits. Okay. So what do we know?
So A is 100.
Okay. And what we don't know is B.
Right.
But what does this mean?
So X is 60, right?
And Y is?
144.
Okay. So if we plug in the 2 points that, or the values for X and Y that we know, well, we'll be able to solve for B. Notice that B becomes the 60th root of 144 divided by 100.
Okay.
Use your calculator to come up with that. Although I almost prefer, since they said write the equation, let's just write the equation using that. So the equation is going to be this. In other words, your final equation always has an X and a Y in it. It's just like whenever you do any of them, where you're talking about direct relationships or inverse relationships, and you have that K, you solve for K using the X and Y that they give you, but then once you've done that and you go back and you give the specific equation, you bring back the X and the Y and you fill in for A and B. All right.
Yeah.
I do actually like this answer better, only because it's more precise. If I actually found the 60th root of that number, it's going to be some irrational decimal that I got to round off. All right. Newton's law of cooling. Let's see if I can finally remember it. The temperature as a function of time is equal to the temperature of the medium plus the temperature of the medium minus the temperature of the original times e to the kt.
It's, I think, e to the t plus k.
It's what?
E to the t and then plus k. I think. I'm not exactly.
I don't think so. Here, let me pull it up again. Which I can't do without erasing what I just did. That's okay. Newton's law of cooling.
According to ugrad.math.ubc.ca, Newton's law of cooling states that the rate
T equals, oh, sure, I can't. That's got to be e to the kt. But they don't show a negative sign on there. Interesting. But I'm quite certain it is negative because it's cooling, right?
Yeah.
If K wasn't negative, then it would be heating up. Yeah. No, K always has to be negative. Well, K can be K. I've never quite understood this. Why some books will put a negative sign in front of K, and then when you figure out what K is positive. Or you can not put a negative sign in front of K, and when you figure out what K is, it's negative. You know what I'm saying? I don't believe there's any difference, but this is the formula.
Okay.
It's e to the kt. Or there may even be a negative sign in front of that. I can't see it. We'll use the negative sign. I honestly don't think it matters. And I see a negative K on the other page also. So I'm pretty sure it is what I had written.
Okay.
So let's start with that. T, the temperature as a function of time. Boy, you don't see that very much. That's Newton's law of cooling only. Temperature of the medium minus the original, all times e to the minus kt. All right. Tell me what everything is.
Okay.
First of all, let's ask what they're asking. Oh, they're going to ask 3 different questions. So let's see. Sitting on the counter in a room that's 20 degrees. What's that? That T sub m or T sub o?
T sub O. Right?
I don't think so. Wow, they gave it to us. I just didn't read far enough. Huh. Why do they have a plus sign instead of a minus sign there? Why is that a plus sign? In other words, 20 degrees is the temperature of the medium.
Okay.
That's the temperature of the room. Okay. In other words, you have a warm bowl of soup that's much hotter than 20 degrees, and the room is 20 degrees, so the soup is going to cool down. Okay. And they give us this formula, which looks an awful lot like the formula I wrote, except for one small thing. They got a plus sign there, not a negative sign. In other words, there's my T is the temperature of the soup in centigrade, where little t represents the time and the soup is sitting on the counter. How can this ever have a plus sign in front of it? Oh, what am I thinking? Yeah, it's got a plus sign in front of it. This has got the minus sign. So this 60 degrees here What's the initial temperature of the soup when T is equal to 0? So just plug in 0 for T, and what do you get? In other words, so far, this does not require Newton's law of cooling. So far, they've just given us an exponential equation, and they're asking us to plug in stuff. In other words, what is capital T when little t is 0?
Okay, so
Any number to the 0 power is what?
0 or
No,
1.
1. So what is T? What's the initial temperature?
So e to the
So all of that becomes 1. Now, what is 60 times 1 plus 20?
oh
In other words, forget this for the moment. I won't erase it because we may need it yet. But don't pay any attention to that. Just plug in 0 for T in the equation they gave us.
right. Yeah, so 60, so 80.
Okay. How many minutes does it take the soup to cool to 40 degrees? So what equation am I going to write? Based on this.
So 40
Bless you.
equals, thank you. 60e to the 0.2027.
Okay.
Plus, or t, yeah, plus 20.
Now solve that.
So
What do we know we're going to have to use at some process to solve this?
logs.
Okay. And in order to use logs, we've got to isolate that first. So get rid of everything else.
So subtract 20.
Okay. And then?
Divide by 60.
Okay, so that is 1/3 on the left side of the equation, and e to the minus 0.2027t. Now what?
Natural log.
Okay, so now we have
Plus,
natural log of 1/3 equals what?
negative 0.2027t.
So t equals what?
Negative 0.2027.
Now don't do it in your calculator, just in other words, give me an exact answer.
So
Dividing both sides by that coefficient.
oh yeah, so
That's
5.
oh, that's the answer right there. We don't really want to take it any further. That is the only exact answer. Now, if he says to the nearest minute or then I would want to convert that. Yeah, he says, how many minutes does it take the soup to cool to that? I still like this answer better. That can always be converted to a number of minutes. But
Okay.
that's a precise answer that we can always go from there. Number C, what does the 20 represent for the graph in the context of this problem? The graph.
So,
Hold on, the graph. What graph? Oh, the graph that we drew. Except our graph didn't have that. No, we didn't graph this.
no, we didn't.
Well, represents that right there, does it not? They just got it backwards. In other words, they've switched it around from Newton's law of cooling. They gave us Newton's law of cooling. It's just they gave us the T sub m, which is the temperature of the medium, at the end. So what does the 20 represent for the graph? I guess it would be a vertical shift up of 20. In the context of this problem, it represents the temperature of the medium.
Okay.
Because of Newton's law of cooling. This problem doesn't seem to me like you really are supposed to know Newton's law of cooling, which I find interesting because didn't we do 2 problems on Newton's law of cooling last time?
Yeah.
And where we had to know Newton's law of cooling, right? No,
Right.
they gave us things like the original temperature and the temperature of the medium, and we had to calculate K and so forth and so on. So it almost seems like they're going backwards here a little bit. They don't even refer to it as Newton's law of cooling. But I don't get it, nor do I necessarily need to. Let's look at the next one. But I believe that's the only answer I can think of for C. What does it represent for the graph? Well, it's clearly a vertical shift. And what does it represent in the context of this problem? Well, the only thing I can think of is the ambient room temperature, 20 degrees. All right, 12 is 3 parts. Let's start with the 3 different formulas at the top. And then we're just going to plug them in.
Okay.
Yeah, in fact, I'll write them down here. I'll write small so we have room. Compounded annual, what's the formula? The general. Always want to remember the general.
So it's
always begins with the initial amount. All of them. Even your rabbit problem. The first thing is the initial amount, always.
right.
What's next?
Then 1 plus r over n.
Not for annual. For annual, well, you could use r over n. It's just that n is 1. In other words, n is the number of times per year it is compounded. So when you're compounding annual, n is 1. You don't need to even write it in either spot.
Okay.
That's T right there. Okay, so that's compounded annual. What is it for compounded quarterly?
A equals a sub o times 1 plus R over 4.
Yeah, excuse me. You were ahead of me. I was right in the general.
And then 4 times t.
And monthly.
A equals a sub 0 times 1 plus r over 12. And then 12 times t.
Okay. Now let's fill in everything. 2,000 is the starting amount, and 2.2 is R, which is 0.022. And T is 30 in every case. So this one is 2,000 times, I'm going to add them together, whatever that number is. That's our first answer. Second answer. And rather than do the math, I'm just going to do it like this. In other words, if you had a certain kind of calculator, you could actually put it in like this,
Okay.
where you just put in 1 plus 0.022 divided by 4. And what's this one? Tell me.
A equals 2,000 times 1 plus 0.022 over 12. And then times 12 times 30, which is 360.
Yeah, I get giant exponents in these problems. You really do. And you wonder how you can have that big of an exponent. It's because the number that's in parentheses is always really, really close to 1. And when you take a number really close to 1 and you take it to a giant exponent, it doesn't increase that much. But you know how to get all these answers out of your calculator?
Yeah.
Okay. You have another page, or is that it?
This is it.
Okay. Do you have any other questions on this one? Did we answer everything?
Yep, we did.
And this is a typo. You can point out to the teacher. That should be that.
Okay.
Yeah, very puzzling as they're not using Newton's law of cooling here. They just gave you this function. Okay, Dimitri, I will talk to you next time.
All right.
All right. Good night. Bye-bye.
Bye.